Okay, folks, so we're going to talk about this. This is percentage composition empirical formula and molecular formula. This is very, very easy. Now, it says percentage by mass of element, right? It says mass of element present in a sample times 100% total mass. Okay, let me explain this to you, okay? Let me explain this to you. Okay, you see here, let's say if you look at this example over here, right? It says 3.65 grams of an oxide of carbon. So what does this mean? It means that there is carbon and there is oxygen. That's it, because it's just an oxide of carbon. It says that there is 2.08 grams of carbon. So this is 2.08 grams. And the total is 3.65 grams. Yes. So I'm sure you know how to calculate the oxygen. Oxygen will be the total, which is 365 minus off from 2.08. This will give you the mass of oxygen. Yes or no? So with that, you'll be able to calculate the mass of oxygen. So let me just quickly do that for you. Not necessary for this question, I think, but let's just do that. 2.08. So oxygen is 1.57. Okay, done. Then it says, hey, calculate the percentage by mass of carbon. So basically, we want to know how much of the entire mass is carbon. So what we did was, we took the mass of carbon and then we divided it with the total mass, multiplied with 100%. So using this formula, right, if I take 100% minus 57%, I will get, what do I get? I get 43%, no? So 43% is oxygen, okay? 43% of 3.65 grams is oxygen. Now, if I do a simple maths here, 43% divided with 100 times 3.65. Let's see what we get, okay? Let's see what we get. 0.43 times 3.65. Hey, wow, interesting. I get 1.57 grams. So you see, okay, it's the same number, isn't it? So by using percentage of masses, sometimes we can also find out the mass of a particular compound. All right. So either way, you can either minus or use the percentage. So in this question, a compound known containing zinc and oxygen. So there is zinc and only oxygen. Okay. So this total is 20 grams. So 20 grams here, you can see here is 4 significant numbers. Yes. After we remove, right? After we remove, there is only zinc left, and this zinc is 16.07 grams. So I'm going to guess the balance is oxygen. Okay. So the balance is oxygen. What would oxygen be? So let's do a simple maths here. 20 minus 16.07. So oxygen is going to be 3.93 grams. Yes or no? So they ask us to find the percentage of composition of the compound. So for percentage of zinc, what we do is we take 16.07 divided with the total mass just now, 20, and then we multiply with 100. And then the percentage of oxygen, what we do is we take 3.93 divided with 20 times 100%. We should get the answer. Okay, so that is how straightforward we can do this. Okay, that brings us to percentage compositions from chemical formula. So in this case, it's quite straightforward. If you look over here, right, sulfur dioxide. So sulfur has the total molar mass is 64.1. So the entire thing is 64.1. So if we want to know sulfur, there is only one sulfur here. So it's 32 divided with 64.1. But oxygen, 16 times 2, because there are 2 oxygens, right? So that's the percentage of oxygen. Simple? Okay. So let's go on. Okay, so we're going to be talking about empirical formulas and molecular formulas. Now, empirical formula, okay, let's say we look at this picture here. Look at this picture here. If you look at this picture here, you realize there are 2 carbons and there are 4 hydrogens. This, what I've written here, is called the molecular formula. Okay, molecular formula. So you see this word here, molecular formula. Now I'm going to abbreviate this word using this symbol, MF. Okay, molecular formula. The molecular formula tells me that there are exactly 2 carbons and 4 hydrogens in this sample. Okay, so that means this, whatever this compound is, contains 2 carbons and 4 hydrogens. So molecular formulas actually tell us, give us a few information. The first information is it tells us what elements are present. Second, it tells us is how many of each element is present. So in this case, I know there are 2 carbons and there are 2 hydrogens. Then what I can do is I can calculate the molar mass of this compound. Yes or no? I can calculate the molar mass. So if I want to calculate the molecular mass, mm, right? So I take 2 times 12.0 plus 4 1.0. So this will be the molecular mass, which would be 28. Okay, 28. Molecular mass, if you remember, no units. If it's molar mass, it has units. Just remember, only molar mass has units. The rest of it, we don't have units. Okay, so done. So this is called mm. Now comes the part where you realize if you do a simple maths here, there is a common factor. We can divide everything in this formula by 2. You end up getting CH2. Correct? So same thing with this thing here. If I divide this with 2 as well, I get 14. Okay. So 2, this number 2 is called n. It's a variable. Okay. Sometimes it can be 3, sometimes it can be 4, and sometimes it can be 1. So if both of the elements have a common factor, we can use it. So now hold on. I want to take you through this. So this was called mm, right? Molecular mass. This, my friends, is called the empirical mass. Empirical mass. Let's find out. Okay, let's do a simple calculation here, right? This is 12 carbon, 12 plus 2 times 1.0. You see, you get 14, right? So the empirical mass. So the mass of the empirical formula, that's called the empirical mass. So what I'm going to do is I'm going to show you a very simple formula here that we are going to be using. So the formula is going to be, okay, molecular formula equals to empirical formula times n. Okay, I think the colors are not very clear. Okay, I'll change colors. Okay, so that's 1. Okay, then we have molecular mass equals to empirical mass times n. Okay, so please remember this. Okay, all right, so we've got 2 of this. Okay, so we got molecular mass equals to empirical mass times n. So let's do some examples here. All right, let's do some examples here. Okay, so one thing I want to tell you is whenever you get questions, right, when you get percentages, I want you to assume that the percentage is the same as gram. Easy. This makes life very easy. So we don't have to worry too much about what is it. So just assume percentage as gram. So if you look at this example here, so the first thing is when you read the question, right, you read the question. In this question, there are 2 elements. One element is called carbon and the other element is called chlorine. So what you're going to do is you are going to calculate the mole ratio first. Okay, so the first thing here is mass. So what I prefer to do is I'll prefer to put, okay, straight line. So I prefer to do this. So carbon and then chlorine, right? So, and then we draw one more line here. And then we draw one line across. Since there are 2 elements, so the first row here, first column here, we put mass, and then we put gram. So what we do is we put here 14.5, and then we put 85.5, right? We don't have to put gram into the this one because we already written gram outside here. Step number 2 is we find the moles. So when we find the moles, right, what you guys can actually do is you don't have to show me, you don't have to show this. You don't have to show this. You can do this on your calculator itself. So 14.5 divided with 12, you get 1.21. And this you get 2.41. Okay, you can just do this on your calculator. You don't have to show these workings here. All right. So now we got mole. Then what we're going to do is we are going to work out the ratio. Now to work out the ratio, what you need to do is you need to look at these 2 numbers here, this number and this number. You have to decide which number is smaller. So you realize 1.21 is smaller, right? So 1.21 divide by itself is 1. 2.41 divide with 1.21 will be, okay, I'm just going to look over here, is 2. So the ratio of carbon to chlorine is carbon to chlorine. The ratio is 1:2. Okay. 1:2. So that's the ratio we get. So we already have the empirical formula here. Okay. So So when we work out the empirical formula, it's very easy. Then what we can do is we can go on to work out the molecular formula. So this is the exact same question just now, exact same question. So they say the molecular formula is 166. That means the molecular formula is 166. So molecular, let me change color. All right, change color. Okay, so molecular mass is 166. So this one is the empirical formula. This is empirical formula. So the empirical mass will be, carbon is 12. There are 2 chlorines. Each chlorine is 35.5. Okay, you can look at the periodic table. And you get here has 71 plus 12, you get 83. So now we have the empirical mass. So what we're going to do is molecular mass equals to empirical mass times n. Okay, so this was 166, this was 83 times n. So n becomes 2. Yes. So which means now we take the empirical formula times with n. This will give us the molecular formula. So it will be CCl2 times 2 equals to molecular formula, which will be C2Cl4. So that's the molecular formula. Okay, easy. So you guys should be able to do all of these questions after this. Same thing, these hydrated compounds, right? Now for hydrated compounds, it's the same thing. It's exactly the same thing, but you see in this case, this entire compound has a mass of 2.56 grams. 2.56 grams, yes or no? Then it says, once you heat it up, you remove all of the water, the remaining part is 1.44. So what actually is happening here is zinc sulfate with unknown amount of water. When you heat it up, so this was 2.56, yes or no? So when you heat it up, you got zinc sulfate and the water is released. So we don't know how much this is, but I do know, according to the question, this is 1.44 grams. So how much of water do we have? So 2.56 minus 1.44, it's 1.12 grams. Okay, so now I know the mass of zinc sulfate, I know the mass of water. So what I'm going to do is I'm going to draw one column here. Okay, and then I'm going to draw another column here. So this is going to be zinc sulfate and this is going to be water. So I first thing I do here is mass. Okay, mass grams. So this is 1.44, this is 1.12. The next thing I want to do is I want to work out the moles, right? I want to work out the moles. So moles will be, so I need to work out the molar mass of zinc sulfate. So according to the periodic table, zinc is 65.4. So zinc sulfate 65.4 plus 32.0 plus sulfate is 4 oxygens, right? Plus 4 times 16.0, I get 161.4. So 161. So the molar mass of this is, okay, so I'm going to just write it over here. The molar mass or the molecular mass is 161.4. I'm going to work out the moles. 1.44 divided with 161.4. I'm going to get, wow, such a small number, 0.00892. Okay, here water I know from my previous calculations is 18. Okay, water is 18. So 1.12 divided with 18, that gives me 0.0622. So what I'm going to do is I'm going to ask myself which of these numbers is smaller, and then obviously I can see that this number is smaller. Yes. So what I'm going to do is I'm going to divide it with itself. I'll get 1. And then this number, I'm going to divide this number with 0.00892. Okay. I'm going to divide it with that 0.008. Sorry. Still getting used to this. 0.0892. When I do that, okay, so I divide this with 0.00892. I get, wow, I get 6.975. So what I'm going to do is, since this number is very close, I'm going to assume that this is 7. Okay, so which means that the formula should have been zinc sulfate dot 7H2O. Okay, 7H2O. So this is water of hydration. So water of hydration, whenever you see the dot there, it basically means, if you want to look it in simple terms, if you imagine this is zinc sulfate, okay, let's say this is zinc sulfate, water is physically, so that means there are 7 water molecules, 1, 2, 3, 4, 5, 6, 7. So there are 7 water molecules attached onto the surface of zinc sulfate. Okay, this is a simplistic way of looking at it. So because it's physically attached, you can use physical means, like for example using heat to remove the water. That's what happens. So that's what the dot basically means. There is a chemical connection there, but for making things simple, we just look at it this way. Okay, so you can see the answer is over here. Now when we come to this, right, when we come to rounding off, what we're going to do is, sometimes when you do ratios, right, sometimes when you do ratios, let's say there's something x, and when you get a ratio, okay, when you get a ratio like 2.5 or 1.25, you cannot round up. Okay, you cannot round up ratios like this. So what you will need to do is you will need to multiply them with some coefficients, like maybe multiply with 2, okay, you get 5. Okay, perfect. This one, if you multiply with 2, you realize you get 2.5. You cannot, right? So you have to multiply again, so you get 5. Am I right? So from the very beginning itself, you may have needed to multiply this thing at the beginning itself with 4. Okay, but usually it's going to be a bit tricky. Okay, let's say you ended up getting something like this. Okay, let's say you ended up getting something like this. Oh boy, now you got 2.5 and 1.25. How are we going to do this? So what I'm going to do is I am going to multiply this with 10. Okay, let me multiply this with 10. So what I'll end up is I'll get 25 here, I'll get 12.5, still cannot, right? I'm going to multiply with the 2, I'm going to get 50, and I'm going to get 25, okay? Oh, this is strange. So I'm going to get 50 and 25. Can I make this smaller? Can I make this smaller? Well, I can, right? This is 1 and this is 2. So that will be the ratio. So there are many ways of working this out. Am I right? Did I get this correct? So 25, 12.5 times 2, get 50, 25. I can make this smaller. Yes, we can do that as well. Okay. But the moral story here is this. Whenever you get ratios like this, let's say the 1.99, you can assume this is 2. Or you get 2.01, you can assume this is 2. Or you even get 0.024, you can assume this is 2. Okay, but if you get funny ratios like 1.33, you cannot assume this is 1. This is wrong. You cannot do that. Or you get 1.75, you cannot assume this is 2. It's wrong. Okay, so you can only assume such things, approximation, if the numbers are like very close, like let's say 2.98, we can assume this is 3. That's not a problem. Or 4.01, we can assume this is 4. Okay. So if you get anything which is not those type of common numbers like 1.5, 2.5, 1.3, 1.6, then you have to start multiplying with 2. Then if this doesn't work, you multiply with 3. If this doesn't work, you multiply with 4. If that doesn't work, try 5. After 5, check your working again. All right, check your working. You could have got something wrong. All right. Okay. Bye-bye.